Hello everyone. So today we're going to be looking at a couple of really important concepts, and that is the application of angle chasing in trigonometry in Olympiads. Now, when it comes to the IOQM or the pre-RMO and such examinations, you don't need a very high level of angle chasing as you would probably need in INMO. In fact, the International Math Olympiad that happened in March 2022, the first one was basically angle chasing, right? It was quite an advanced illustration of angle chasing. So, but yeah, if you figure that out, then you're pretty good in angle chasing. But at the IOQM level, it's mostly just elementary angle chasing and working with trigonometry. It's usually a combination of these two. So we're going to see one such problem that will come in the IOQM. And yeah, let's see how we can work with that. So this is the problem number 24 from the IOQM in 2021. And in this video, we're going to be looking at elementary angle chasing, applications of trigonometry, certain book sessions for the IOQM, and at the end, a similar but challenging problem.
This video is sponsored by Cheenta.com. Since 2010, Chinta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
Okay, so what does it say? It says a light source at the point 0,16 in the coordinate plane casts lights in all directions. A disk, a circle with its interior, is defined like disk is to be considered circular, right? Of radius 2 with center at 6,10, casts a shadow on the x-axis. The length of the shadow can be written in the form of m root n, where m and n are positive integers, and n is square, free find m plus n. So if I just consider this to be the disk, and this is the center of the disk, okay? And let's say this is my coordinate plane, and let's say this is the source of the light, right? Let's say, let me just extend this actually a little bit, right? Let's say this is the source of the light, and the light is essentially casting light in all directions, radiating light in all directions. So what will be the shadow of this disk? This entire portion will be the shadow of the disk, right? Now this is 0,16. This is center C, and C is at 6,10. And let me just label these points. Let's say this is A, this is B, this is C, this is D, this is E, right? And let me just join these. So this will obviously be perpendicular. And let me just connect this. Okay. Now then we have this. Now this will be theta and this will be theta. This is a very famous configuration. For example, if we have this circle, we know that tangents from a common external point to the same circle are equal. This becomes 90 degrees. So these two triangles are actually congruent. So this angle theta, this is also theta. This is a very commonly known result. How is it congruent? Well, this side is equal to this. You have a right angle and you have the common radius, right? So it is congruent by side angle side SAS. But okay, once you have gotten this theta comma theta, what else can we say about here? Well, this radius is 2. They've given us the radius is 2. Then can I find out the length of AC? I can actually find the length. What will be AC? This is the distance formula. AC squared is actually 6 squared plus 6 squared. So AC will be nothing but 6 root 2. Right? And let me just label this point as X and Y. So CX is actually 2. So what will this be? So AC squared is equal to 4 plus AX squared using the Pythagoras theorem, right? So AC squared is 72 is equal to 4 plus AX squared. So therefore AX is root 68. In other words, AX is actually 2 root 17. And this was in fact theta. If you actually see angle XAC. Angle XAC is theta, right? So what is tan theta? Tan theta would be 2 by 2 root 17. So therefore tan theta is 1 by root 17. And this is actually very important because that actually clears up a lot of things. Why? Because I can actually make certain conclusions from this. Now, what will be the slope of line AC? Slope of line AC will be 10 minus 16, there will be 6 minus 0. So slope of line AC essentially is minus 1. How does that help me? Because if I just redraw this diagram over here, right, we had something that looks like this. Right, this is A, this was point number C. The slope of line AC is minus 1. So if slope of the tan theta is minus 1, so theta is 135 degree. Right? So effectively, if this is AC, then this becomes 135. Now, what is this? And this is 45. Here is where the angle chasing point comes in. Okay. This is theta. Now, how much is this? 135 minus theta. Right? Using angle sum property for triangle. How much is this? This will be 45 plus theta. Similarly, now if you look at this triangle, this entire thing over here, if I consider now this triangle, right, this is theta, okay, this is 135. How much will this be? 45 minus theta. So effectively, what is left? What have we kind of deduced from this problem? We have deduced a couple of things, right? This is actually 45 plus theta. This is actually 45 minus theta. This entire length is how much? 16. Why? Because you see, this point A was at 0, 16. So this entire length is actually 16. Okay. Excellent. And if and tan theta is how much? 1 by root 17. So after this, it is just application of trigonometry that we had studied till like grade 9th and 10th, elementary. If I just consider this to be A and this to be, what do we have to find? B. We have to find B, right? The shadow that this figure casts on this, on the x-axis, it will be B. So we need to find B. Now, just applying trigonometry, what is tan 45 plus theta? Is 16 by A. Now, let me just write down a formula. Tan A plus B is tan A plus tan B divided by 1 minus tan A tan B. Right, this is a very famous trigonometric formula. So tan 45 plus theta will be 1 plus tan theta divided by 1 minus tan theta. That is 16 over A. Right? Now, so 1 plus 1 by root 17 divided by 1 minus 1 by root 17 is equal to 16 by A. So 16 by A is effectively root 17 plus 1 divided by root 17 minus 1. Right? So A is essentially 16 times this quantity. Root 17 minus 1 divided by root 17 plus 1. I'm not going to rationalize this because it's really not necessary. Now you look at this entire triangle. 16 by A plus B. 16 by A plus B is tan 45 minus theta. Now I'll write another formula for you, which is tan of A minus B. And tan of A minus B is nothing but tan A minus tan B divided by 1 plus tan A tan B. Well, perfect. Because now you have 16 divided by A plus B is equal to 1 minus tan theta divided by 1 plus tan theta. Right. So 16 divided by A plus B, what will it be? 1 minus 1 by root 17 divided by 1 plus 1 by root 17. Okay. So 16 divided by A plus B would be nothing but root 17 minus 1 divided by root 17 plus 1. And root 17 plus 1 divided by root 17 minus 1 would be A plus B divided by 16. So essentially, root 17 plus 1 divided by root 17 minus 1 would be equal to A by 16 plus B by 16. And if you remember, what was A? What was A? A was 16 times this quantity, right? A was 16 times root 17 minus 1 divided by root 17 plus 1. So A divided by 16 would be just this radical expression. So root 17 plus 1 divided by root 17 minus 1 would be equal to root 17 minus 1 divided by root 17 plus 1 plus B by 16. Now, root 17 plus 1 divided by root 17 minus 1 minus root 17 minus 1 divided by root 17 plus 1 is equal to B by 16. So if I just simplify this, B by 16 actually becomes root 17 plus 1, root 17 plus 1 times root 17 minus 1, and this becomes root 17 plus 1 whole squared minus root 17 minus 1 whole squared. So B by 16 actually becomes 17 plus 1 plus 2 root 17 minus 17 minus 1 plus 2 root 17, because minus minus is plus, and this one 17 minus 1 is 16, so 16 gets cancelled. So B is effectively 4 root 17, and they've told us that B is in the form of m root n. So m is 4, n is 17, and we need to find out m plus n, which is 21. So yeah, that was actually a very interesting problem. A little bit of maybe like a challenge solve, I guess, because it's a word problem. So the major kind of idea was understanding this diagram. if you are able to form this diagram, after that there are a couple of ways to do this. One of them is the trigonometry method that I showed, which is quite interesting actually, and nice application of it, which you may not usually see in textbooks, but in general a pretty elementary, pretty nice application of it. The other way that I found was if you have a little bit of knowledge of coordinate geometry, right? So this is an external point, right? What is the general equation of a couple of tangents from an external point, right? Two tangents, the pair of combined tangents equation. It's like t square is equal to s times s1, right? Pair of combined tangents equations. And that is another method that you can use to solve. It's a little bit lengthy and it's probably like a little bit more rigorous. It would involve a little bit of knowledge of coordinate geometry, but that's also a very good method to solve it. But yeah, I like this method. It's a little bit more synthetic, a little bit more easy to understand, I would say, and can be understood by anyone who has done trigonometry. So yeah, I hope you like that and I hope you are able to understand it. So let's move forward. Okay, so here's some book sessions for the IOQM: Challenges and Thrills of Pre-College Mathematics, Mathematical Circles and Russian Experience, Excursion Mathematics, A Test of Mathematics at 10+2 level, Elementary Number Theory by David Burton, Elementary Theory of Numbers by Sierpinski, Principles and Techniques in Combinatorics, and of course, Problem Solving Strategies by Arthur and Gell. And at the end, we have a similar but challenging problem, and this is actually very interesting. And this is again just pure trigonometry bash. You just need to perform trig bashing, and you don't really need coordinate geometry over at all, I would say. Trig bashing should be more than enough for this. So yeah, if you're able to solve this or kind of get any progress on it, that would be great, because this is not the easiest problem in the world. If you get the approach, it will be fairly easy, but unless you get the approach, it's kind of hard. So if you're able to make any progress on it, let me know in the comment section and I'll help you out. Until then, I'll see you in the next video. Thank you very much. Bye-bye.
The programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Cheenta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Chinta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit Cheenta.com.